First and foremost, they certainly want to describe themselves as builders. Self-performance of building is the foundation of their business, which was started back in 1864. It's one of America's oldest privately owned construction firms, one of the top 10 US commercial builders with headquarters in St. Louis, 9 offices nationwide, and experience of working in 45 states, with 80% repeat work from clients from a diverse array of commercial and industrial building categories. So moving on to Chris, our guest presenter is a VDC Director for North Pacific Division of McCarthy Building Companies. In addition to his academic and professional achievements, Chris is proud to have served as an infantry captain in the Army, and he contributes to many BIM advisory bodies, including the California Department of Correction and Rehab. He lectures widely. The goal at McCarthy is to be the best builder in America. They understand that as the builder, they need to be in control of the entire project, and they understand a BIM process enables this. McCarthy are using Tekla and Trimble branded products to achieve their goal. So, without waiting further, let's hear from Chris what they're doing. Over to you, Chris.
Thanks for everyone who can join us today. I want to be talking about Kaiser Oakland Medical Center replacement hospital project located in Oakland, California, and McCarthy's use of virtual design and construction on our project. If you follow along this wheel, you'll see that there's a life cycle flow of information, starting from the design phase, working all the way around to get to the point of operations, facilities operations in CMMS and a CAFM system. Today we're going to focus on just 4 aspects of that, which is change management, control and layout, floor monitoring program, field verifications. In our change management process, we started with modeling the ideal process. This is really critical for success. You start with the ideal process, and then you select your tools with the expectation that you're going to customize those tools to support that ideal process. You know, the nature of the beast with hospitals is they are continually changing, not only through design, also through construction, and then after they're delivered to the owner as well. There's going to be changes, there's going to be change orders, they're just part of the deal. There's always an owner expectation of incorporating these changes, you know, with minimal impacts to schedule and cost, and that's always going to be challenging. Especially BIM projects, they have a time component that oftentimes is forgotten, and how that coordination needs to happen prior to rolling into fabrication and then installation in the field. So going back to that process, understanding what that is to really align the expectations from all the project participants, make sure they're all on the same page starting from the beginning. It allows the owner to make better informed and timely decisions, prioritization of the changes, because there are going to be a number of different changes that are happening concurrently, but you can't do everything at one time, so you do need to prioritize those. What happened on this particular project is that we had to go back and reevaluate our process and really optimize that, which freed up the log jams that had happened. It's a large project, so we do have our fair share of number of ACDs, and then we need to also address how to mitigate schedule delays incorporating these changes into the project. There's also, you know, as you get into a large project, there's a limitation of resources, and they're always going to be in competition with production in the field, and managing that is important. And then, you know, seizing that opportunity of that change, how do you really establish and put into place the desired infrastructure to manage that change for the project? One of the key things we do on this project is we use Tekla Construction Management Module to identify changes in the subtrade coordination models. This is important because for every change, obviously we got to go back to the owner and justify cost impacts. And being able to isolate just the changes from the adds and the deletes allows us to be able to communicate much more efficiently with the owner on what those changes are. That really provides the backup and the support for any type of cost proposal for those changes. Stepping into the next area of our control and layout, we took a different approach on this project. I started out with basically calling everybody into the project and mind mapping all of the components, all of the different key considerations to going into this. This was not just McCarthy staff, but our sub-trades as well. This brought the team together to align everybody's goal into one common outcome, to identify the requirements to provide standardized training, which allowed everybody to be on the same page, which addressed the risks and concerns for all the participants. And then we had participation in the game. We actually have guys out running Trimble equipment out on site, and that are providing the control and the layout, actually control for the layout for our sub-trade partners. And what this does is provided a path for everybody to be able to be confident and trust and a clear path moving forward. Starting out with that control is recognizing that you need to align the physical world with the virtual world to facilitate the transfer of those points. So going out to the project site, reestablishing 000 on the project site so it is alignment with the virtual world. And as you can see from the left, here's a picture of the site, and you can see where our control points are set up out there. So everybody can go back to those control and know exactly where they are and are confident that that physical control is the exact same control as what's in the models. And then on the right, what you can see is how are we taking that absolute control that's out on site and transferring it to a relative control that are on the floor. And those controls, as you can see, we have quite a few more control points on those floors than you would typically see on a project. And this was determined early on to really expedite the sub-trades rollout and their implementation of their Trimble and establishing all of the locations for all their inserts. It was determined that having this additional number of control points was really going to help expedite the schedule. So as you can see from this image, we're depicting here basically all the floor inserts that are supporting the mechanical and the plumbing, electrical, fire protection, all the systems that are in that space. And reflecting back to that change management slides that you saw earlier, this is tying back into that one repository of information. So that way we're trying to manage the changes that are happening as they roll out and tying that into the next workflow, which is really laying out the physical work out in the field. And what this does is allows us, and the Tekla allows us to be able to take that information more seamlessly into our Trimble robotic total stations, so that way we have the most up-to-date and most accurate information on doing that layout that's out in the field. So it's tying in that field production flow back into how we're managing the changes, making sure that everybody's on the same page at the same time. And here's an example of one of our guys out in the field actually using the piece of equipment. So leveraging the success on that, it was recognized that we've got basically now internal crews running our own control for sub-trade layout. We've purchased the equipment. We've got skin in the game. We're doing this ourselves. We're providing that mentoring, that training for all the sub-trades. It's a mixed spectrum of guys when they come on board. Some have some experience and other guys have no experience. And getting them all to the same common point of understanding so the whole team is moving forward and progressing at the same pace, which is important. And they've got the confidence that we're there to support them and we're going to help them and train them as needed and make sure that they're doing a good job. From that example, on the hospital alone, we've got between 8,000 and 9,000 inserts per floor. This allowed us to be able to get all the deck inserts prior to placement of the concrete in half the time with obviously much better accuracy than any other type of traditional layout. This also allows us to be able to back check the sub-trades layout and avoid conflict from everything from curtain wall to stairs to other subs laying out even for their deck inserts. Just kind of doing that spot check here and there, being able to pick up any of those issues prior to that work being permanent in place and avoiding issues down the road. And then finally, this allows us to be able to do our field verifications and as-builts, and I'll talk a little bit more about that here in a few minutes. A key part of McCarthy is in our internal quality control program. One of the differentiators that we have is it's an enhanced floor monitoring program. In that program, there are two key components that I'm going to talk about today. One is the structural survey, which basically takes and monitors all the structural systems prior to placement of concrete and post placement of concrete. And then if you have any type of shoring, post shoring removal. And then monitors and records the displacement of that structural system as it's progressing through the construction. Second key piece of that is our floor profile testing, which is tying back to ASTM 1155M, which is really monitoring the floor flatness of the finished concrete and the floor levelness. So on this particular project, we had a requirement of a floor flatness of 28. Other considerations that we had to take into account was slab thickness, obviously not overloading the floor during a pour, monitoring that, follow-on grind fill considerations, how is that going to impact the finished systems that are going on those, to the impact on the flooring subtrades. And other considerations such as framing, door header placement, fixture placement, and etc. The quality of the final conditions, and then owner satisfaction. So one thing about this project is that this was rolled out a little bit later. We had already kicked off the project, and we were kind of playing catch up to put this in place. And I'll talk a little bit about how we went about doing that. So on this project, it's a very aggressive schedule. Construction was already well underway, and we couldn't incur any delay in that schedule. So whatever we needed to do couldn't impact the schedule. Costs were already set in an INGMP. We didn't have a lot of additional funds to go back and add to that. So, and then the quality of the survey was also a constraint. It had to be equal or greater than traditional methods. And the bulk of the individuals on this project, their experience was obviously limited to traditional methods, so there was the people factor of it as well. So what we did on this project is we actually went out with a 3D laser scanner and captured the as-built point clouds of the steel to be able to capture those existing conditions now of that work in place of the steel. From there, we can create our known measurement points along combining back with our models that tie back into our structural and rest of our systems that are tied back into the change management system that we've got in place. And from there, monitor the displacement of each of those points to be able to produce what we have are our pre-pour and post-pour survey plans. And with these plans, what we're doing is we're actually identifying what the locations of each of those points are prior to placement of concrete, and then you can see here in the difference in the numbers of how much deflection or deviation there's been since the placement of the concrete. And recognizing that the building is settling as we're loading that building, so really taking the differential of those numbers to then take the next step, which is to do a beam deflection analysis. From there, we're identifying what beams are high. On either the camber didn't relax, or the camber came out perfectly, or the camber came out a little bit more than expected. And from this, documenting what the results of the performance of that structural system, and then passing that on to the structural engineer, help the structural engineer to be able to assess the performance of that structural system to ensure that there were no issues and that we can proceed without any problems down the road. So the next step of the floor flatness test, as you can see here, this is an excerpt from one of the reports. ASTM 1155 basically calls taking a piece of testing equipment and walking those lines that are indicated on this graphic that you see here. And from there, a report is generated. And in that report, what we have for this particular area that we're presenting here came out with a result of a floor flatness of 54.25. You look at that and say, hey, that's pretty good. I'd be happy with that result. So did we stop there? No, we actually took it further. We took our 3D laser scans of our concrete decks, brought those back into Trimble RealWorks, and produced the topo plans. These topo elevation separation of the lines are set at 1/100th of a foot separation. From there, we can bring those back into our CAD environment, overlay the architectural, and what we see from there is really what the impact or not of any of the particular areas. You can see from this example, when we overlay the architectural along with those topos, we really see what's happening in that area. each individual specific area. We're identifying where areas may be high, as indicated here in the magenta, 3/100th of a foot high, or low, that are 3/100th of a foot low. And with that architectural overlay, we can see where we really need to be addressing and proactively looking at either grinding areas that may be high or filling areas before rest of the work goes in place, or do we fill it in later to get that perfect floor flatness, that the owner is expecting. And what that does is it allows us to be able to proactively, up front, identify any trouble areas and then have our plan to address those throughout the rest of the project, rather than running into surprises down the road. And this also helps confirm locations for setting benchmarks for header heights, carriers, plumbing carriers in the walls, to specific focus of critical areas such as ORs. Anywhere there's sensitive areas that we can put a heightened focus of attention to those. And so what you see here is basically a zoomed in view of what that would look like with those hatch patterns of the highs and the lows as we identified. And keep in mind, these are only 3/100th of a foot that we're really highlighting through here. So we're getting into really a heightened level of quality control here. So the results of this process that we went through, we validated the survey, the quality of that survey. We actually did a small portion in the traditional method and validated that this process that we go through is actually just as accurate or more accurate than having different surveyors come out and survey the same thing. Also, the schedule outcome was a 70% reduction over the traditional. We had the schedule estimates from a traditional surveyor, what it was going to take to do that. We were able to perform this in a reduction, again, of 70%. Also, the cost, reduction of 66%. Which is really big. And when you're looking at a big job, a 70% schedule reduction and a 66% cost reduction adds up to a lot of dollars and time. Additionally, this enhanced program allows us to basically mitigate field conflicts that are down the road and allows us better planning. And ultimately, we provide an enhanced customer satisfaction. I mean, that's a net result that you look at, is elimination of waste and cost and schedule and a higher customer satisfaction. So as a part of our quality control program, this has actually been a very good result coming out of this. Moving into the next area, use of the equipment, the Trimble robotic total stations for field verifications and the laser scanning for field verifications. Here is an example A3 identifying a conflict out in the field. As typical on any project, the way the work gets put in, you'll from time to time run into a conflict. From the time we were notified there was an issue between the two different trades of going out, capturing the points with our robotic total stations, bringing them back to that repository, centralized repository of information where we can check against not only the coordinated models, but the shop drawings that are derived from those models, and then determine who actually deviated from that plan, and then send correction notice out to the subtrade with what they needed to do to correct that issue. That whole entire process actually happened in less than 3 hours. So we see that as really much gain and not only in the schedule, but cost, conflict resolution, and it really has helped keep the project going. Additionally, capturing your existing conditions or your as-built as you're building them with 3D laser scanning is very important as well, because what it does is it allows you to be able to capture all the rest of the minute detail of that exact, accurate as-built that you oftentimes won't get out of a coordinated model. Decisions are made on what level of detail they're going to go into the model, and it doesn't include absolutely everything. Whereas when you come in and accurately capture all those conditions prior to closing up walls and ceilings, really provides the rest of that information. So the facilities and the follow-on operations has complete information. So in summary, our change management program that we've implemented here, it's optimized the management of those changes, really allowed us to get a handle on those and proactively manage those. We've not had any schedule impacts. Considering all the number of changes we've had on here, we've been able to feather them in, so to speak. The control and the layout has been great. It's not only advanced McCarthy, but our sub-trades, and allows us to control the schedule and the accuracy of that layout, which is key to a successful project. And enhancing our QC program with a floor monitoring program not only exceeded our expectations, but also the client as well. Kaiser was very happy with the outcome of that, and they've actually looking to make that as a standard requirement on all their large jobs. And then the field verifications that we've come out of here, building to that model. Not only are we planning, but we're building, and we're going back and we're verifying that the work in place is as planned and built to that model, which is important.